Countdown.
Tahniah! Siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia. Sebuah inisiatif e-didik Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Bismillahirrahmanirrahim. Assalamualaikum, salam sejahtera, and hi all teachers, parents, and our wonderful students out there. Welcome again to Pusat Tuisyen Academy YouTuber, a joint venture with e-didik Malaysia and Kelab Guru Malaysia. Bermula percuma, selamanya percuma. Before we proceed, let's begin with the recitation of Kitab Al-Fatihah for Muslim, and for the non-Muslim, please recite your prayers according to your religion. Al-Fatihah. Okay, how everyone doing today? My prayer that everyone is the best of health and ready to proceed with today's class. Let me introduce myself first. I'm Miss Wahida Binti Zakaria, Miss Wawa, as a moderator for today's class. Currently, I'm teaching at Pahang Matriculation College, Pahang, and together with us is Madam Nur Faizah Binti Ahmad, our host controller. And our observer is Madam Rosmaya, a Form 6 Physics teacher at SMJK Yuhua Kajang, Selangor. Assalamualaikum semua.
Assalamualaikum. Selamat malam.
Selamat malam. Both of them will ensure our class today's session running smoothly. And the most important person today is our presenter, Madam Naini binti Harun, Form 6 teacher at SMK Sultan Sulaiman, Terengganu. So let us give a warm welcome to our presenter. And for the record, we are now live on her YouTube channel, Naini HR, with our topic, movement of substances across membrane. So let's support this channel to grow by please click the subscribe button, okay, and hit the bell button. Not forgetting our channel too. As usual, the lesson will last approximately 1 hour, and the certificate link and the claim and the credit claim link will be given at the end of this session. And please note that you can use e-didik or MOE email address to claim the certificate for this class. And in order to claim the credit claim, to do the credit claim, you need to collect the codes that consist of one single capital letter and also the 4 digits, so which will be announced separately during this class. So be sure that to follow our class up until the end. Just a reminder, please use appropriate words and also the profile picture if you wish to post comment in the chat box. And I'm pretty sure all the students here are excellent students with positive attitude. And stay focused, and if you have any question, please write on the chat box and we'll give our best to provide you with the answers. And before I pass to our presenter, let's mention the first digit for claim credit code. That is A1. A1, okay? A1. Okay, Madam Naini, let's start.
Okay, thank you, Miss Wawa, as moderator today, and thank you also to my friends here, okay, head panel, Cikgu Faizah and Madam Rosmaya. Okay, so first of all, let me introduce myself. Okay, my name is Naini Harun from Pusat Tingkatan 6 SMK Sultan Sulaiman, Kuala Terengganu. My teaching experience is 23 years and teaching biology STPN, also SPM, and I'm teaching biology STPN p.m. about 7 years. So my channel, Cikgu Naini HR. Okay, so this is my channel. Okay, and you can find out more content video about biology here. Okay, don't forget to subscribe also. And other teammate, okay, this biology prayu is head by Cikgu Nafaiza Ahmad here. Okay, Cikgu Nafaiza from College Matrikulasi Negeri Sembilan Kuala Pilah. Okay, and her teaching experience 26 years, 15 years in boarding school and 11 years at College Matrikulasi Negeri Sembilan. So her channel, Cikgu Faiza. Okay guys, please also subscribe her channel. This is also our teammate, okay, not here today. Her name is Fatia Binti Masul, also from PTE, SMK Seri Sedang Selangor, and her teaching experience almost 30 years and 20 years in Fongsik. And her channel is Cikgu Fatia 66. Okay, so guys also subscribe her channel. And the sweet one, our moderator, Cikgu Wahidah binti Zakaria, okay, her from College Matrikulasi Negeri Pahang, okay, and teaching experience 11 years, teaching biology in matriculation. Okay, so her channel, Oh My Biology by Miss Wawa. Okay, so guys, don't forget to subscribe her channel. Okay, so others team for Max, okay, which held on Saturday at 5 p.m. Okay, which is led by teacher A. So the others, teacher Zainaria and teacher Aileen. Okay, these others gang. On Sunday, there are Kimia Prayu, okay, which held on 3:30 p.m. Okay, which is led by Cikgu Shahnan and the others. And also here physics, okay, which is led by Madam Rosmaya, okay, here in our county, which is held on Sunday at 5 p.m. Okay, and others also have Perakaunan Ekonomi, which will be held Wednesday at 9:30 p.m. and led by Madam Fizi. Okay, so the others team. And also you can get other STPM subject for pengajaran, muat, pengajaran perniagaan, perakaunan STPM. And all of these you can find out at www.academyyoutuber.com, okay, our portal, or you can find out by apps. You can download through your phone or laptop. Okay, so this app, there are a lot about the video from standard, okay, from and other, okay, in these apps. Okay. Okay. So what we want to discuss today, okay? So today our topic is transport or movement across plasma membrane. Okay, this is continue before that my live, okay, last week about plasma membrane. So today we want to discuss about the transport or movement across plasma membrane. Okay, this is actually for STPN SEM 1, okay, new student. Okay, so you all must be able to explain the process of passive active transport, endocytosis and exocytosis. Okay, and you also must explain about the concept of water potential, okay, solid potential and pressure potential, and also calculate. Okay, this is important. So this one is hot topic in structure and also objective. Okay, in our matriculation for SEM 1, there are also students must explain the various transport mechanism across the membrane about the passive and the active. Okay, so same as our in STPM semester 1. Okay, so let we revise, okay, about what we have learned last week. Okay, so the characteristic of cell membrane. Okay, the cell membrane is selectively permeable. Okay, that means allows some substance to pass through, but does not allow other substance to pass through. Okay, there is the most important characteristic for cell membrane, which is selective permeable. Okay, so how it permeable? So permeable for what? Permeable for lipid soluble molecule. Okay, remember they has phospholipid bilayer. So they allow the lipid soluble molecule across through, and also small non-polar substance, okay, non-polar substance due to its hydrophobic region of phospholipid bilayer, okay, and it impermeable two polar molecule and ions. Okay, small substance such as gases, okay, can cross through the lipid. Okay, enable cell to retain polar molecules and ion within the cell. Okay, so mostly important for the cell. Okay, so actually this the process, the movement across membrane you already learn on form 4 okay, for SPM. Okay, so for STPN a little or more explanation about this. Okay, so the type transport, they have the passive and the active transport. Okay, so what is the passive transport we want to discuss today is about simple diffusion, facilitated diffusion, and osmosis. Okay, and for active transport, about the potassium pump, okay, and also the other for bulk transport, there is endocytosis and exocytosis. Okay, so under endocytosis, they have phagocytosis and pinocytosis. Okay, so what is the important thing is you must know, you must define what's this process. Okay, so this here, okay, this is example, the diagram. Okay, actually this diagram can come out in structure question. Okay, so remember, for passive transport, the arrow must cross through the phospholipid bilayer, and also for channel, okay, channel protein, because they don't need energy. And sometimes for the carrier protein, but important thing is passive, no energy is needed. Okay, so the active transport only involve carrier protein plus energy. Okay, so remember the diagram, okay, and the process that occur, okay, either passive or active. Okay, class. Okay, so teacher want to go through speeding, okay, because this one you already know before STPM. Okay, so we only revise the definition. Okay, so what is a passive transport? Okay, so the passive transport is, okay, movement of a substance. Okay, we can use substance, okay, because substance is referred to the, okay, what molecule, okay. So movement of a substance from higher concentration to lower concentration gradient. Okay, or we can say it down a concentration gradient. Okay, so either you use from higher concentration to lower concentration, or you use movement of a substance down a concentration gradient. Okay, the same idea. Okay, across a selective permeable membrane. Okay, and then without using energy. Okay, for definition, the mark will given about 2 marks, 2 points, and although they have 3 points. Okay, 2 marks. Okay, this is passive transport. Okay, the diffusion. Diffusion refer to simple diffusion and facilitated diffusion. Okay, so simple diffusion is the movement of a substance from higher concentration to lower concentration gradient across phospholipid bilayer. Okay, so across phospholipid bilayer without using energy and without the help of a transport protein. Okay, so the molecules can diffuse easily across phospholipid. Okay, so we use the word of diffuse. Okay, we cannot use move, because move, they are the move refer to the way. Okay, the way diffuse. The simple diffusion, diffuse. Okay, diffuse easily across phospholipid. Okay, so you see, okay, you see the arrow. Okay, so that means the non-charged molecule can cross through phospholipid bilayer. There are also water, the polar molecule, and you see the charged molecule and ions cannot through. Okay, so the others non-charged molecule, okay, they also lipid soluble molecule. Okay, and okay, this one is oxygen for non-polar or uncharged molecule, non-polar. Okay, small. Okay, the words is also small. and the other one is more refer to the polar molecule, okay, H2O, okay, water. And water also can cross through channel protein, okay, so by the osmosis. Okay, so this one is the substance that can pass through the phospholipid bilayer, okay, by simple diffusion, okay. Okay, how about the facilitated diffusion? Okay, so the differences between the simple and the facilitated is about the protein. Okay, so the movement of a substance from higher concentration to lower concentration gradient across plasma membrane with the help of transport protein. Okay, transport protein, there are two main types. Okay, either channel protein or carrier protein. Okay, so you can use channel protein, okay, facilitated diffusion, and also carrier protein. Okay, but the carrier protein, they no need energy. Okay, so okay, compared to the active, this protein is used without energy. Okay, so what are the substance? Ions, the polar molecule, okay, such as glucose amino acid, okay, they cross through by facilitated diffusion, but cross through the protein. Simple cross through phospholipid. Okay, so remember the differences between two process. Okay, and the other one is osmosis. Okay, so osmosis only involve the water molecule, and water if diffused through what we said channel protein. Okay, from higher water potential to lower water potential region. Okay, so remember in STPM we use a water potential. Okay, not the high concentration gradient of water. Okay, we use higher water potential. Okay, so by the end of our class we more discuss about water potential. Okay, that is a main idea in osmosis. Okay, so osmosis is the movement of water molecule from higher water potential to lower water potential region. Okay, and must across the selective permeable membrane without using energy. Okay, so we already discussed about the passive transport. Okay, okay, so we go through. Okay, continue to the active transport. Okay, so for active transport, okay, this about the movement of ions, okay, or molecules across a cell membrane aided, okay, with the aid of a protein pump, or protein carrier, okay, with a specific binding site against concentration gradient. Okay, so the differences between the passive, okay, the passive is down concentration gradient, the active is against concentration gradient, okay, and require the expenditure of energy provided by ATP. So need energy, okay. And the cell which occur active transport have high respiratory rate and a large number of mitochondria, okay, to generate a high concentration of ATP. So the active transport, they occur more in the cell which have a large number of mitochondria, especially in our muscle or our cell. Okay, what I say, they respiration cell. Okay, so they need a large number of mitochondria, and there is the active transport there. Okay, so this is active transport. Okay, involve the carrier protein and the ATP. Okay, and then the other one is against concentration gradient. Okay, so you see this molecule. Okay, this is against. Okay, there are high concentration here, from low to high. Okay, this high. Okay, this low. Okay, and active transport, okay, beside of the protein pump, okay, there are also for bulk transport, for that carrier the vesicle and so on. Okay, so there are endocytosis and exocytosis. Okay, so the endocytosis, phagocytosis and pinocytosis. Okay, so this one is need energy, okay, because it's the active transport. Okay, so what's endocytosis? Okay, so the endocytosis is phagocytosis. Okay, C, phagocytosis, phago. Okay, that means they have pseudopodium and then they make a phagosome, food vacuole. The pinocytosis, they involve the fluid. Okay, receptor-mediated endocytosis. Okay, because certain membrane they have receptor. Okay, so there are receptor-mediated endocytosis. Okay, this is the diagram about the three process. Okay, so we discuss a little bit about this. Okay, phagocytosis. Okay, see the phagocytosis. Okay, remember the what we say amoeba, how amoeba eat. Okay, that means the keyword for phagocytosis, that means they have a pseudopodium and then they surround the solid vesicle. Okay, they surround the food and then they make the vesicle. Okay, so you describe the first one is folds of plasma membrane and cytoplasm. Okay, plasma membrane. Okay, and then form cytoplasmic projection. Okay, this projection sometimes we call it pseudopodium. Okay, the cytoplasmic projection we call it pseudopodium. Okay, pseudopodium. Okay. Okay, remember the amoeba process. How amoeba eat the the food particle. Okay. And then fuse together. Okay, fuse together here. Fuse together. Okay, fuse together. Trapping the solid particles within a vacuole. Okay, so the vacuole. Okay, so the vacuole we call it phagosome. Okay, so it becomes a phagosome. Okay, so remember the phagosome will bind with the lysosome. Okay, where lysosome can what we say digest. Okay, digest the food particle in the phagosome. Okay, so the surface of vacuole is derived from the plasma membrane. Okay, so become the vacuole. Okay, the phagosome and move into cell and fuse with lysosome. So lysosome digests particle with its hydrolytic enzyme. Okay, so the example, the nutrition in amoeba and also in our white blood cell, leukocyte, neutrophil or macrophage, okay, which engulf foreign substance such as bacteria or what we say virus and so on. Okay, this is phagocytosis. Okay, Miss Wawa, there. Okay, so there are 8 more before what is it? Rest. Okay, I continue to exocytosis. Okay, phagocytosis.
Madam Naini,
Yeah.
before you proceed, can I announce the second code?
Okay, can.
Alright. So the second code is number 1. Number 1. Okay.
Okay. Proceed. Okay. So, okay. Okay, so the pinocytosis, okay, not exocytosis, pinocytosis because this is endocytosis, they have what we say, phagocytosis, the pino and the receptor mediated, okay. So pinocytosis, okay, so pinocytosis, folds of plasma membrane invaginate inward forming a flask-shaped vesicle, okay. So droplets of extracellular fluid contain dissolved particles flow inside the vesicle. Okay, that means there are fluid here. Okay, so the plasma membrane fold invaginate inwards. okay, like engulf also lah, okay. And then the fluid, okay, the fluid, okay, containing particle will inside the vesicle. Okay, so they fold and become vesicle. Okay, the vesicle we call it Pinocytic Vesicle. Okay, and the vesicle is pinched off, okay, to form a Pinocytic Vesicle, okay, that contains fluid and dissolved solute in cytoplasm. Okay, so the Pinocytic Vesicle will fuse with lysosome, and what lysosome do? Digest. Okay, digest the fluid that contain dissolved solute. Okay, so same idea with the phagocytosis. The differences is the pinocytosis refer to the droplet of fluid, okay, cair fluid. Okay, compared to the phagocytosis, there are the solid, the such as bacteria, food, okay, so on. Okay. Okay, so the last one for endocytosis is a receptor-mediated endocytosis. Okay, this is for the cell which plasma membrane have receptor. Okay, so the selective uptake of specific macromolecule, okay, macromolecule, okay, molecule yang besar such as glucose and so on, okay, and the coated pit form the vesicle, okay. Okay, coated pit forms a vesicle when a specific ligand molecule, okay, such as cholesterol molecule also, bind to the receptor. Okay, so here ligand, okay, ligand molecule is an example of cholesterol molecule. Okay, bind to the receptor. Okay, here bind to the receptor. Okay, and then on the cell surface, and trigger the inward folding of plasma membrane. Okay, so the plasma membrane also fold, where the receptor they have a ligand. Okay, so when folding, it will become also vesicle. Okay, but we call it coated vesicle. Okay. Okay, so the last one. Okay, the last one is exocytosis. Okay, the exocytosis. Exo, that means will the vesicle will move and then secrete out the content. Okay, the endo into the cell. Okay, this outside cell. Okay, so exocytosis move a material across membrane. Okay, egestion or secretion outside. Secretion outside. Okay, so you see it, this vesicle, and then bind with the plasma membrane and then secrete out the content in their vesicle. Okay, so vesicle membrane incorporate into plasma membrane. Okay, that means bind to the plasma membrane, helping to restore membrane use in endocytosis. Okay, and then content in vesicle are released outside the cell. Okay, such as the extracellular enzymes, hormone, excretory products. Okay, so we finished already about the process, the movement across plasma membrane. Okay, passive transport and active transport. Okay, so
Okay.
yes.
Madam
Stop lah.
Naini, can we have a break?
Okay,
Why?
so we break. Yes. Okay.
So we
Continue.
will continue after this.
Okay, see you after
Okay.
this.
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata ganjaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Okay, welcome back, students. So, our class today, tonight is the movement of substances across membrane. So, you may proceed, Madam Nunaini, please.
Okay, so we continue. Okay, this is about the water potential. Okay, so water potential, the hot topic for STPM now, the calculation and also the the explanation about water potential and osmosis. Okay, osmosis we already defined. Okay, and now we deep into the what we say the about the water potential. Okay. Okay, so water potential. Okay, potential that means tendency of water molecules. Okay, to move from one area to another area. Okay, the symbol we use this one. Okay, what we call it psi, whatever. Okay, and the pure water that means no mineral whatever in there. Pure water. Pure water has the highest water potential. That means pure water is 0 kPa. 0 kPa, the highest water potential. Okay, pure water. And the formula. Okay, so remember the formula. Okay, so bio as also physics. Okay, this one. They have formula and they have a calculation. Okay, so water potential is equal to pressure potential. Okay, so remember pressure potential is the pressure inside the cell. Okay, that means if outside the cell there are no pressure. Okay, solute potential. Okay, the solute refer to the solute in the solution. Okay, in water. Okay, solution. Okay, so this is symbolized by psi S for solute and psi P for pressure. Okay. So remember this formula and remember also pure water have a size 0, okay, 0 kPa. Okay, so in that formula, we must also know the solute potential. Okay, so the definition for solute potential is a measure of the change in water potential of a solution. Okay, so a solution due to the presence of solute molecule. Okay, that means there are solute in the solution. Okay, there are the solute potential. Okay, so when solute molecules is dissolved in pure water, it reduces its water potential and becoming negative. So remember, solute potential is always negative. Okay, and the pure water have 0. Okay, so the solution with less solute then the other has higher water potential. That means if solution has higher water potential, there are less solute there. Okay. Okay, so the other part in the formula is pressure potential. Okay, so the pressure potential tending to force water from one place to another. Okay, based on mechanical pressure. Okay, mechanical pressure in plant cell, and the pressure potential usually positive. Okay, so the solute is usually negative. The pressure potential usually positive in plant cell. Okay, but certain negative is in xylem. Okay, so as usually is positive for pressure potential. Okay, so pressure potential increases as water enters cell. Okay, and in plasmolyzed cell, okay, the what we say the flaccid cell, pressure potential almost 0. Okay, that means no pressure there. Plasmolyzed cell, almost 0. Okay, so let we see what happened in the isotonic solution. Okay, so remember you already know the isotonic. That means the solution that equal water potential inside and outside. Okay, and then there are no movement, no net movement of water, no change of the cell, and the water move in and out of the cell at the same rate by osmosis. Okay, so for STPM there are experiment about this solution. Okay, remember for potato so teacher hope you already do the experiment. Okay, so this is isotonic solution. So there are water potential is equal. Equal, that means no net movement of water into or out of the cell. Okay, so how about when when cell put in the hypertonic solution? Okay, the hyper, that means the cell has higher water potential than outside the cell. Okay, so outside the cell, so that means water will move out from the cell by osmosis. Okay, so the animal cell become cremated when in the hypotonic solution. Okay, so higher water potential inside. Okay, here higher water potential. Okay, compared to the outside. Okay, so hypotonic solution, that means more solid there. Okay, so the water must move out from the cell by osmosis. So animal cell become cremated. Okay, how about plant cell? The plant cell become also become plastic, like plasmolyzed. Okay, plasmolyzed cell. Okay, and then what happened when this cell, blood cell, is put in the hypotonic solution? Okay, so hypotonic solution, the cell has lower water potential than outside cell. Okay, that means outside more water. Okay, more water, less solute. Okay, so water move into the cell by osmosis. The animal cell will swell and then burst. Okay, for blood cell, they don't have cell wall. Okay, so in plant cell, they will terjik, span and terjik. Okay, terjik, because for plant cell, they have cell wall. Okay. Okay, so the summary for that process, okay, when water diffuse into plant cell, it enter vacuum, okay, because water in plant cell will enter the vacuole, so the vacuole enlarge, create pressure towards cytoplasm and cell wall. Okay, what teacher said, terjit, because there are turbo pressure. Also, we call it pressure potential. Okay, so remember, the pressure potential always has positive value. Okay, and see the pure water. Okay, pure water is 0 kPa. Okay, that's it. And the point at which plasmolysis is just about to happen, incipient. Okay, so see the movement of water molecule. Okay, you see water with high water potential. Okay, here, and then it's low. So the water move to the low water potential, or the negative. Okay, negative water potential. Okay. Okay, so we go to the practice. Okay, this is about the calculation. Okay, calculation of water potential. Okay. Okay. Okay, adakah teacher laju kat sini? Boleh je. Hopefully, okay, if you do not understand, you can jot down at the comment. Okay, about the formula and so on. Okay. So let's see the question. Okay, so teacher discuss more about the water potential. Okay, about maybe 4 situation. Okay. Okay, so example, the first one. Okay, this is cell A and this is cell B. Okay, actually if they have this cell, the first of all is you must find out the water potential. Okay, for this cell and for this cell. Okay. Okay, so given the solute potential is about negative 8 MPa, not kPa, MPa. Okay, this is M. K and
Megapascal.
M. Ya, lagi besar dia punya nilai dia. Okay, and the pressure potential is 3. Okay, so how we calculate the water potential? Okay, so remember the formula is water potential equal to psi S. Okay, that means solute potential plus psi P to pressure potential. Okay, so the water potential is negative 5 MPa. Okay, just what we say apa?
Substitute.
Substitute. Okay, that's okay. Just calculate plus only. Yeah. Okay. Negative 8 plus 3, again you get a negative 5 MPa. Okay. Okay, so the others for the cell B. Okay, cell B negative 10 MPa for solid. Okay, and then pressure is 0 MPa. Okay, so what is the answer? Okay, either you want to try to answer. Okay, the simple one.
Anyone?
Okay, this is the simple one. Go through with the calculation of a formula. Okay, simple calculation. Okay, just okay. Okay, so
At this moment tak ada lagi yang komen dia answer. It's okay.
Okay, so we go on. Okay, negative 10 plus okay, so we get in negative 10 MPa. So the answer is negative 10 MPa. Okay, this is simple. Okay, so we go to the little bit difficult. Okay. So this one is a cell, only one cell, cell A. But cell A is in sucrose solution. So sucrose solution is size solute. Okay, they have negative 1000 kPa. And then the cell A is negative 500 kPa for solute. And the pressure is 200 kPa. Okay, so the first one, you must calculate the water potential of this cell. That means the water potential for cell A. Okay, so how we calculate? Okay, using the formula. Okay, water potential equal to psi S plus psi P. Okay, so we get it negative 500. Okay, so negative 500 plus what? 200. Okay. So, okay. It's hanging. Okay. Okay, so the answer is negative kPa. So remember to use a unit for your answer. If not, cannot get mark. Okay. Yeah, so state whether water will move in or out of the cell. Explain. Okay, so this is negative 300 kPa inside cell. Okay, so okay, so the arrow, so water will move in or out the cell. Okay, see the sucrose solution is solid is negative. What is it? Okay. Okay, you see the first one.
Kilopascal.
Okay. Yes. Okay, for this one, okay, just okay, so the sucrose solution, they have psi S, and okay, so the pressure is 0, because the 0 pressure for the what we say outside cell, there are no pressure. Okay, so outside there for water potential is negative 1000. Okay, so here is negative 300, and this one is the water potential is negative 1000. So the movement, the water will move to the region that more negative. Okay, that means lower water potential. Okay, so here is higher water potential, and this one is lower. So the water will move what? Move out. Okay, so water move out from the cell by osmosis because the cell A has higher water potential than surrounding solution. Okay, okay, so use the
Madam Naini, sorry to interrupt you. I want to state the next quote.
Okay.
Can I?
Yes. Yes.
So the next code digit is number 6. Number 6.
Okay.
You can proceed.
Okay, so the last question is what happened to the volume of the cell? Okay, so when water is moves out of the cell, so the volume will,
Volume decrease.
yes, the volume will decrease. Okay. Okay, this situation when they have one cell and then in the sucrose solution. Okay, so remember how to find out the water potential. For what we say for solution, okay, there are no container or cell. The pressure is zero, so remember. So you can find out the water potential outside, okay. Okay, so we go to the example, okay, the example number 3. Okay, so they give you two cells, the adjacent cell. So you must calculate the water potential of cell A and cell B. Okay, so the first one is we must find out water potential for cell A and water potential for cell B. Okay, so how we calculate? Okay, use the same formula. Okay, for cell A, negative 2200 plus 1000. Okay, so cell A we get negative 1200 kPa. Okay, so how about cell B? Okay, cell B. Okay, negative 1600, okay, plus 800. Okay, so the answer is negative 800. Okay, so the movement, okay, if we, okay, there is the question asks the movement of water. So how the movement from cell B to cell A or cell A to cell B? Okay, so the movement of
Comparing.
water, yeah, the movement of
Com-
water. You teacher Wawa?
by comparing the value of water potential kan. So
Yes.
we can determine the direction of water between
Yeah.
the cell kan.
Yeah. Yes. Yes.
Since no student try to answer.
Okay.
So
Let me answer. Okay. Okay, teacher Wawa can explain a little more. Okay. Boleh je? So the movement is from
so the movement is
cell
from
B.
yes, cell B into cell A.
Yeah, okay. So guys, student, remember the movement
Yeah.
must be from
Okay, we have
uh,
we have yet hit link. Yet
yeah.
sorry. Had Yi Ing, susahnya nama dia. Okay, so had
Okay.
I think this is a male student.
Uh-uh.
Cell B to cell A.
Yeah, okay,
The
that's correct.
answer.
Okay, so the
Mm-mm.
movement of water to the more negative. Okay, so
Yeah.
high to low. Okay, remember the negative value. Okay, so more large number of negative, that means negative value. Okay, okay, that is.
Less
Yes,
water
yes.
potential.
Yeah, okay, so sometimes student, this one,
Confused.
confused.
Mm-mm.
Yeah, yes, that is. Okay, so we go to the next, a little bit difficult. Okay, state the direction. Okay, between two cell and give a reason. Okay, so that continue. Okay, we already answered that. Okay, so the movement is flow from B to cell A. Okay, and cell B is higher water potential than cell A. Okay, so we go to another question. Okay, so to calculate the final values of water potential and pressure potential after equilibrium is reached. Okay, so remember the water will move from cell B to cell A, and now these two cells achieve equilibrium. Okay, so we must find out the final values of water potential. So the water potential will change, and also pressure. Okay, and sometimes in question they will say the solute is negligible. Okay, that means no change in solute. Okay, but this one we must find out a final values of water potential. Okay, so how we find out the final values of water potential? Okay, remember equilibrium is reached. Okay, so the water move until equilibrium is reached. That means isotonic, okay, in two cell. Okay, so what happened? Okay, so final values of water potential. Okay, at equilibrium, okay, the water potential for cell A equal to water potential for cell B. So that means we must, divide by two cell. Okay, because this is the equilibrium reach. Okay, so negative 1200 for cell A plus negative 800 for cell B. Okay, so divide by 2 and we got the answer negative 1000 kPa. Okay, this is the final value. Okay, remember, guys, you must show the calculation. Okay, to get 2 marks for the answer and the calculation. Okay, and don't forget the units. Okay, this one. Okay, so we must find out the new pressure potential, okay, after equilibrium is reached. Okay, so we already have water potential of these two cells, that is negative 1000. Okay, and so we must find out the new pressure. Okay, so how we calculate this? The final pressure potential. Okay. Okay, so the final is pressure potential. Okay, so the water potential is negative 1000. Okay, so plus plus. Okay, dia punya deduct. Okay, deduct by solute side. Okay, because the formula is okay. We want to find out the pressure. Okay, so negative 1000 and then deduct by negative 2200. Okay, so use either this one. Okay, not this one. Okay, but sometimes in question, the solute, you just choose only one. Okay. Okay. So the answer will be 1200 kPa. Okay. So this is the new pressure potential. Okay, the final pressure potential when the equilibrium is reached. Okay. Okay. This is for the the question. If the state the equilibrium is reached, so remember we must find out the new water potential and new pressure potential. The solid potential sometimes not change. Okay, either we can use for set A or set B. Okay, like that. Okay, so good luck lah sekarang. Okay, tak ada satu lagi ni mungkin missing.
Ada lagi soalan.
Okay lah.
Any
Tak ada dah.
tips? Any tips, Madam Naini? Any tips to answer these topics?
Okay, for these topics, okay. For water potential, the tip is remember the formula, okay. And then equilibrium, we must find out the new, okay, new for water and new for final pressure, okay. Okay, so the others, okay, for active transport and passive transport, the diagram of the plasma membrane, okay, and then the process, okay, process for active transport and passive transport. Okay, if you see the past year question, they are, okay, come out the structure question. They give you the, the structure of plasma membrane. And then you must we must guess the process, okay, either active or passive. Okay, so remember the definition and the process, okay, and the diagram of plasma membrane. Okay, so other question from student to ask.
Okay, so far no. Okay, can I add some tips? For example,
Okay.
if the question give the condition of cell is at turgid condition. So if the question not state the water potential of the cell, so we must know that the turgid cell has water potential value of 0 kilopascal or megapascal, right? Okay,
Yes.
cikgu.
Okay. Yeah. That's it.
That is number one. Number two, if the medium is not exerted with any pressure, so the pressure potential is 0.
Yeah. Okay. And remember also the pure water. Okay. The
Pure
pure
water,
water
yes,
is
the
0. And
water
also the
potential.
solute. Okay. The solute, they are usually negative, and the
Yeah,
pressure is usually positive. Okay. Because when
yeah.
negative plus positive, the answer is 0. Okay. For water potential. Okay, so this is what I will say a simple calculation. Okay, that actually we come up in objective question and also structure. Okay, for essay, maybe the comparison, okay, between the solid potential and the pressure potential or water potential. Okay, that's it. Okay, Cikgu Wawa.
All right.
It's very,
So before that, I would like to give the next code. The digit actually is 5, not 4. All right. So at the early, I state that it has 4 codes. It actually 5 codes. Okay, with the start with a capital letter. Okay, of A letter. Yeah, capital A letter. Okay, and then followed with several codes that I already state. Okay, so any comment? No, any
no comment.
no comment. Okay, any advice from other teacher?
Okay, especially the
Advices,
by teacher.
Madam
Okay,
Nafaiza?
immatriculation, they must also what we say the calculation of water potential, Cikgu Wawa.
Yeah, yeah,
So
yeah.
that's the idea.
Sama-sama.
Okay.
And
Okay.
this is quite difficult if if no exercises done by
Hmm.
student.
Yes. Okay,
All
and
right, so
confusing.
yeah,
Mm-mm.
okay. So Alhamdulillah, we have reached the end of today's session, today's class. So congratulations to all those students who are able to follow our session from the beginning till the end. Before we end our session for today, okay, please stop posting your comments for a while, and if you haven't clicked the subscribe button yet, please do so and make sure it turns to a grey color, not the red color, okay? And activate the icon bell so that you will not miss the next session and help us to grow our channel. Then if you find this lesson was beneficial, click like and share to your friends and your social media, spread and share the goodness. Once completed, type done on the chat box before the certificate link is given as a token of thank you for your dedication in joining our class online today. And I think link for the certificate and link to the credit claim are already given in the chat box. And please take note, the link will end half an hour after this live ended. Make sure to use the EDD or MOE email log in, okay, to log in. And incorrect email use will be not entertained. And if you haven't got one, please apply first. And the link to apply the EDD email is also given in the chat box. And if you wish to get more information on the online classes, go to our portal www.academyyoutuber.com. And to those who haven't joined the EDD Junior Telegram yet, please do so. And so once again, I would like to thank all the members in this class. Okay, Puan Faizah and also Madam Faizah and also Madam Rosmaya, and especially our presenter, Madam Naini. Okay, and remember that more classes you join students, the more credit claim that you can claim. Okay, and feel free to share this free tuition again. Okay, and this is the collective effort from all the teachers throughout Malaysia for all the students throughout the country. And thank you too for being a YouTuber Academy supported too. And I think that's all for this class now, and see you in another session. Ingat hashtag bermula percuma, selamanya percuma. Stay safe till we meet again next week, the same day, same time on Saturday at 9:30 p.m. Bye semua. Assalamualaikum.
Thank
Bye.
you. Bye.
Wow, banyaknya hadiah menarik menanti anda.
Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma.
Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang.
Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi